exercise 164, page 418, question 9. We have a function here that describes the current in some sort of circuit which has a wave function associated with it. We know that's the case because we've got a sine function in there, and the amplitude of the wave is given by, or depends on t as well, which is this term 15t in front. You remember that the number in front of the sine function gives the amplitude, so if that was just 15, it would mean an amplitude of 15. But in this case, the amplitude actually depends on the time, so the amplitude is increasing as time goes by. And you can see if you look at the wave, that the amplitude is increasing as time goes by. What we're interested in is what the rate of change of the current is when the time equals 0.1 seconds. Well, this is 1 second here, so 0.1 seconds is going to be quite close to the beginning of the function here, so we should get a reasonably small value for the rate of change of the current. Remember that di by dt tells us the rate of change of the current, which is the gradient of the current. So what we're finding is the gradient of this line when time equals 0.1. So I'm expecting a positive value, probably quite a small value because it's not sloping very much. So the process here is to differentiate the function with respect to time and then put t equals 0.1 in and to calculate it. The function has got time appearing twice, so we need to use the product rule. So I equals 15t times the sine of 3t. So what we do is we let u equal 15t, and we let, that means that u by dt equals 15. We let v equals sine 3t, which means that v by dt equals 3 cos ut. And we plug these values into the product rule, which we should be familiar with now. The rate of change of I this time with respect to t equals the first part times the differential of the second with respect to time, plus the second part times the differential of the first with respect to time. So that means di by dt equals u, which is 15t, times the v by dt, which is 3 cos 3t, plus v, which is sine 3t, times the difference of u with respect to time, which is 15. So tidying this up a bit, we get 15 times 3, so di by dt, 15 times 3 is 45, t cos 3t, that's 15 sine 3t. So that means the rate of change of current with time equals 15. Is common to both terms. We can take 15 outside the bracket, leaving 3t times the cosine of 3t plus sine of 3t. And the tidying up makes it easy to put the value in at the end. So what we're after now is to find di by dt when t equals 0.1. So put t equals 0.1 into the function, and di by dt equals 15 brackets 3 times 0.1 is 0.3 cosine of 3 times 0.1 is 0.3 plus the sine of 0.3. And now we put this into our calculators, not forgetting to make sure that the calculators measuring in radians, and you should get the answer in the text.